Okay, so we're going to use this for synthetic division. I think I walked around and I saw everyone did a really good job. So in synthetic division, you take the opposite of this. Since it's positive 2, we're going to write negative 2. Then it's x to the third, which is 1. Notice there's no x squared, so I have to put a placeholder, which is 0. Then my next one is negative 3, and then 2. Don't forget that there's a line that goes between the linear term and the constant term. We learned that in 5.5. We're going to bring this down, which is 1, or maybe 5.3. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 3 plus 4 is positive 1. Negative 2 times 1 is negative 2, and we have a remainder of 0, which that ultimately, that's what we really want, okay? So today what we're going to learn is if we have a remainder of 0, that means that x plus 2 is a factor, right? So if this was x to the third, this is going to be x squared. This will be minus 2x plus 1. Remember, it's always, your answer is always going to be 1 less than what you started out with. So this, I use synthetic division, and that's your final answer. Okay? How'd you guys do on that one? Good? Okay. Number 2, factor this. So 8 is a perfect cube and 125. Anytime you have two numbers, there's two things you need to check out. Are they perfect squares? Are they perfect cubes? Now, if it's a 3, you need to check out if they're perfect cubes. And the first thing you need to do is, like I said on Friday in my video, is you need to see if they have a GCF. Well, 8 and 125 don't have a GCF. So the next thing I'm going to do is see if it's a perfect cube. It is, and because it's a difference of cubes, I'm going to use this formula. If this is minus, this is always positive. They're always the opposites. So, the cube root of 8x to the third is 2x. The cube root of 125 is 5. So that means that my a is 2x and my b is 5. Don't worry about the signs. All you need to know is which one's a, which one's b. Well, a is 2x. So a squared, 2x times 2x is 4x squared. Plus ab, that means a times b. 2x times 5 is 10x. And then 5 times 5 is 25. And that's how you factor it. That is my final answer. So, can you pull out a GCF? And if you can't, is there a 3? Are they perfect cubes? If they're not perfect cubes, then you can't do that. That only works because 8 and 125 are perfect cubes. If they weren't perfect cubes, then we couldn't do that. Okay, so number 3, I asked you to solve this little problem here. Okay, so this problem is a mixture of chapter 5 and chapter 4. So in chapter 4, I told you, once we learned this method, you were expected to know it. So this is 1. So I'm looking for two numbers that when I multiply, I get negative 21. And when I add them, I get negative 4. So what are two numbers you can multiply to get negative 21? Negative 7 times 3. Why did you pick 7 to be the negative? Because the b was negative, so the larger number needs to be negative. Negative 7 plus 3 is 4. Perfect. So I'm going to split. You know how we would usually do it, and it would be x minus 7 and x plus 3? That's because half of 2 is 1. Well, what's half of 4? So that's the first thing, because x squared times x squared is x to the fourth. Now it says solve it. To solve it, we learned this in chapter 4. Well, how do I solve? So I set them both equal to 0. So now what do I do? Well, what do I have to do first? Now what do I do? Now I take the square root of both sides. And how many answers do you get when you take the square root of something? 2. So this becomes plus minus the square root of 7. Okay, x squared plus 3. What do we do? Now, what do I do? Okay. What is the square root of a negative number? What do you pull out automatically? I. And can you take the square root of 3? So there are your answers. Now I want you to check out something. What was your highest exponent? 1, 2, 3, 4. 4 roots because you have an exponent of 4. Okay, you ready for the last one? Okay, so this is it has an x to the third, right? So 64 and 1 don't have anything in common, but is 64 a perfect cube? It is, right? 4 times 4 times 4. Is 1 a perfect cube? Yes, it is 1. So it's addition. So see up here, the reason I did this on the same card is this was a difference of cubes. This is a sum of cubes. Now watch, if that's positive, notice it's the same formula, but what's different now? Yeah, this is positive, this is negative, because this is positive, this is positive. The cube root of 64 is 4. The cube root of x to the third is x. The cube root of 1 is 1. A is 4x, b is 1. So a squared. 4x times 4x is squared. A times b. 4x times 1? 4x. Remember, this was minus, so I put minus. And now b squared. What's 1 times 1? Okay. So when you go to solve a sum of cubes or a difference of cubes, this you're going to set equal to 0. This you're going to use the quadratic formula, always. Anytime you have a sum of cubes or a difference of cubes, the first set of parentheses is perfect. You set it equal to 0. The second, you have to use the quadratic formula. Okay. That's 1. Then this right here, let's see. Oh, it's 16 minus 64. Now, your job is to make sure that you can reduce all of that. You can pull out a 4. Do you see that? You can pull out a 4 out of everything. So your final answer would be this. Okay. You're like, oh, okay.